Welcome to this video. In this video we are going to look at a very specific situation. Many times we are building applications where the database might be in different databases. Now those databases could be homogeneous. They could be two different databases of MySQL or two different database servers of MySQL. Or those databases could be totally different databases. For example, part of the schema is in Postgres and another part of the schema is in MySQL. Now we should clearly understand when things exist across different databases, some of the things will not be available for us. For example, things like foreign key constraints will not be available to us across tables, but we still should be able to use them as seamlessly as possible. So in this particular video we are going to look at this aspect. So for example, for a sample we are going to take one database in MySQL. This is the same database that we have been already using, and another database we are going to start by having it in Postgres. So let's first set up our database in Postgres. So I assume you have Postgres installed. If not, you can go ahead and install it. After that, the Postgres comes with this command line called PSQL. We will use that to set up a database. So I'm just logging into Postgres. Now we got it. Now we want to create a database. So let's say we don't want to call it video tutorial, but let's say we want to call it, let's say this is a data stream. So let's say we call it data stream. Now we want to create a user. So let's create a user. And let's again call it data stream. And this is just an example. You can choose whatever you want. And let's say the password is data stream 123. So this is the password, and then like in MySQL we have to grant all the privileges. So we grant all the privileges on database data stream to data stream 123, and data stream 123 the password, just data stream. So we granted it. Now our database is set up. Now what we need to do is we need to go to our application.properties file and provide properties for this particular database. So we already have the MySQL properties which are here. Let's just make a copy of those and replace them. So let these be the Postgres data properties. Now we have to give different property names. So let's say rather than spring.gpa we will call it ds. ds is for data stream. So we will call them, all of them will become ds. We can get rid of the dialect, we don't need it. No, we will actually need the dialect, so let's call it and this will, we can, the highest version class that is available, even though we are using Postgres 13, but if you go you find the maximum is 10, so we will just use the PostgreSQL 10 dialect here. Now we need to make some changes. Of course the URL cannot be jdbc.mysql, it has to be jdbc.postgres. The port number is 5432, that is the default port number that Postgres uses. And again the database name and all these parameters after that we don't need. We just give database name, which is data stream. Then we look at the username. Username will become data stream. Password will become data stream 123. and we don't need to give driver class name, we can just get rid of it. Hibernate will figure it out on its own. So these are the changes to our application.properties. Now let's look at the next thing that we need to do, which is basically how do we organize it. So if you really see, when we define, so right now we have been using a default, when we use any database using Spring, there is a set of classes that are required. We basically need an entity manager factory, we need an entity manager, and then we need a transaction manager. When you define these set of properties that we had earlier defined, which is these set of properties, these are the default properties, and Spring Boot performs this operation for you. It's going to create one data source that will be using all default options. Now once we go down this path, which is to have multiple databases, we are going to eliminate that default thing, and we are going to define our own everything. So to do that, we basically need to define a configuration. So let's go to configuration class, and we say new Java class, and let's call this particular class default database config. So this is the class that we are creating, and along with this we are going to define some more things. So first thing, this is a configuration, so we call it configuration. Then we enable transaction management for it, because we will be using transaction. Then we say enable JPA repositories, and within that we provide one entity manager factory reference. So we say entity manager factory reference equal to, and within this we provide the name of the bean that we will be using. So for this particular thing we will use entity manager factory, which we will define in this class itself. And then we have to say what are the base packages that will have all the entities related to this. This is where we are saying where the repositories are going to be. So we define base packages equal to, and we can take this particular path and dot. So the default ones are here, repositories. So that is going to be our default path for the default database config. We need to change the class name, it has become config.u. So let's refactor, rename, and we want to get rid of that u. So once we have done that, now we need to worry about all those properties that are defined in application.properties, and we need to pull them here. And so we use @value annotation to get all those values, and let's put it here. Now I've just copied and pasted this particular code, and these are basically our annotations. We have driver class name, URL, driver data source username, password, DDL auto, and dialect. Once we do that, now even when we define two particular data sources, we still have to tell Hibernate what is the default data source. So this is what we are going to characterize a default data source, and the correct way of doing it is defining a bean which is annotated with primary. So we define a bean that is annotated with primary, it is also annotated with bean, and so let's call it entity manager factory. This is the name that we have defined on top. So this is the name of this bean is entity manager factory, and then we go ahead and say public local container entity manager factory bean, entity manager factory bean, we can just call it entity manager factory, and this basically takes two arguments, this particular function. One is it needs a entity manager factory builder, it needs an entity manager factory builder, and it needs a data source. So for data source, we are again going to qualify it by saying that we want to use the default one, which is named data source. We will name the other bean will be named something else. So we say qualifier, and within the bracket then we say data source, and data source. So these are two arguments that this guy needs. Just for readability sake, let me move this thing down so that things are fitting within the screen. Now once we have defined it, basically what we do is at this level we are going to take care of two properties that were defined. So let's get them here. First we create a map. So map has to be string comma object, and these are properties. And we basically are going to put two properties. One is hibernate dot HBM to DDL auto, and here we are going to pass the value that we got, which is within DDL auto. And then second property is hibernate.dialect, and here we are going to pass the dialect variable that we got. Once we have these two properties, we create our builder. So to data source, we just pass data source that we got. Now there is a packages argument, and this is where we are telling it where are going to be our entities. So our entities, again, we can take this path and then make it, call it dot entities. And then we want to say what is going to be the persistence unit. Let's call it default PU. This is again we are a name that we are providing. Then we inject all the properties that we have just defined, and then we can say dot build. So we have created our entity manager factory like this. The second step that we need to do, the another thing that we need to do is to define the data source itself. And within data source also, this is our primary data source. So we define this, and here the name is equal to data source. So this is the name of that bean, and then we define a public data source, and then we use a return data source builder. So we are looking at the data source builder dot create dot driver class name dot URL dot username dot password, and then we say dot build. So this is how we created a data source Again, let's put it in multiple lines so that it becomes more readable. So we've defined, now the only thing that is left to define is a transaction manager. So again, we follow the same circus. We define it as a primary. Then we say bean. Basically, we are telling that this database is the primary database. So unless there is another database defined for a specific purpose, for everything else, it will use this database. So we have a transaction manager. Then we define the method. Platform transaction manager. Transaction manager, and this method takes a entity manager factory as a argument, and we know we are going to use the same entity manager factory that we defined on top, so we just provide it here. Again, let's make it in 2 lines so that it is a little bit more readable. And then from there we can just return new JPA transaction manager, and we pass the entity manager factory to it. So this qualifier, we forgot the at here, that's why it is giving the syntax error. At qualifier, entity manager factory, and then we forgot the type here. Entity manager factory, yeah. So this is our first database data source ready. The only thing additional that I would do here is, because we can set the default value of driver class name as null, just in case it is not defined. And I think that should be, but actually we shouldn't do that. So we have the first one, and now what we are going to do is we make a copy of it and we define a second data source. So second data source, as we all understand, is about the Postgres. So let's call it refactor copy class, and rather than default data source, we will call it data stream data source. This is for the data stream type of data which we want to go to Postgres, and in that basically we have, so first thing is we change all these values. These has to be ds dot, not spring dot, because that's how we had defined them in our application.properties file. And the data source function can be all right. Only thing we have to change the name, because there can't be 2 beans with the same name. So let's call it ds data source, and rest all is the same thing. Then the entity manager factory, we do the same thing, we change the name. And again, I think only thing is this qualifier we have to change, because we will use ds data source. Other things are fine. Now we have to make a decision here. We have 2 separate directories for repositories, but do we want entities also separately? Let's for now keep the entities in one directory, and we will try, and then we will see whether it works or not. If this has an issue, then we will change it. So let's call it DSPU, and then transaction manager, that name also we will change. This also become DS entity manager. and the repositories we have to put them in separate directory. So tutorial.repositories, ds.repositories we will call them. So they will be in ds directory, and this entity manager, transaction manager also will be ds transaction manager, and entity manager factory will be ds entity manager factory. I think that is just about it. So this is the other config that we have defined. Now after this, now we have to make sure that the primary annotation is removed, because there can only be one primary and the other set of data source methods are primary. This is not primary. If we have two primaries, we will give a conflict while running. So this is what we have. And now let's just define a repository that is in the other data source. So we exit it here, and let's say we have a very simple table which basically contains a time series name value pair data. I am just making it up. So we create a package ds.entities, ds.repositories, and within the ds.repositories we want to create a, let me just make a copy of a repository, user repository, just copy this. So before that we also have to define an entity. So let's call it data source, data entity, and this data entity, as we said, essentially contains timestamp. So let's copy some of these annotation and we will change them. Let's call it at entity. So I'll rename it to time series data entity, time series entity. So let's do refactor, rename, and we change it to time series entity. Then we take all this, let's call the table name as time series, and we know the table is going to have private long ID. This is the ID of the primary key of the table. This would be just a running number. Then we will have a private date, timestamp, and then we will have a private string. Let's say this is our key, and then we have a private string that is our value. And on ID we will put ID as a thing. And then we will have a unique constraint that for a given timestamp and a key, we should have only one row. So let's call it timestamp key, and the column names is timestamp and key. And let's get rid of all others. So we have one basic table here. Let's do an auto generation of keys. So we add this as well, and then we can just define getter setters for this class. Generate getter setter, and this is our entity. Now let's go and define a repository. So we go to ds.repositories. Let's call the Java class time series entity, and we will change it to interface, and it should extend CRUD repository, and the entity should be time series entity. Oh, this should be time series repository, not time series entity. So we have these now. Yeah, I think we can just try them. So if we run them now, ideally we should be seeing a new table being created in the Postgres schema. So let's first run it and see what happens. So we got some error. So it didn't get the Spring JPA properties dialect in the okay, so let's see. It's okay. Then the default database config, it didn't find the dialect. So let's just add a null value there because we don't really need it. The new MySQL, the latest one, there is only one dialect that supports now all the variants. So we can just go and actually we can just remove it from the config. So let's go to our config, which is the default database config. Let's get rid of dialect and let's get rid of the dialect property from here as well. Let's run it again. We again got an error. So it's not finding the driver class name. So driver is org.postgresql. So let's update the application properties. So let's copy this. And we, rather than Spring, we make it DS, and it is com.postgres is com.org.postgresql.driver. So this is the driver class name we gave. Now let's go back to see where we are using this property. Oh, it doesn't go there, so let's now let's exit this mode. Now we go back to our data source for data stream, and we had it, so I will just undo some of those things that I deleted. So this will give us a driver class back. Let's run it again. Again some error. It's saying authentication failed for user. Okay, the password I have given wrong. It should be 123, not 123, 123. We are making progress with each step. Yeah, it seems to up and running. Now to test it, let's go to the Postgres database and see. So we change the database to data stream, and then we say /dt. It doesn't have any tables, so it did not really create any table. Okay, so by default, Spring only performs the automatic schema creation for the objects that exists on the default data source. For others, you have to define your own. So let's go ahead and we create the table manually ourselves. So of course we can't have column name as timestamp, so we have to annotate it. So let's change it. Let's call it TS. And let's get rid of date time. And let's call it TS here as well. So table is created. Now to test it, we have to write an endpoint, but right now what we are going to do is just in the application, in the post create of application, we can probably do an insert just to make sure the data sources are working. So let's write a post construct here. We have to do a post construct because we have to wait for all the Spring context to be initialized before we can do it. So now let's say public void initialize. Now we define a repository here, so we can auto wire the repository, private time series repository, and we can create a time series entity, new time series entity, set key, let's say we can call it key 1, set timestamp, let's put the current time, set value, let's call v1, and then we can say tsc dot time series repository dot save tsc. So basically we are just forcing creation of a row in the table. Let's rerun it and see what happens. So we got an error, and okay, so it's basically giving us error because we have used auto increment, and it is not having the hibernate sequence method. So it seems in Postgres this is not managed as a table, it's a sequence. So we'll drop the hibernate sequence table and we'll create a sequence. Now let's run it. So now we are getting a permission denied. So we have to grant permission for this. So we can say grant usage, select on sequence to okay, it seems to have worked. But there are no values here. We also need to add transaction management ref equal to ds transaction manager. That is the name that we have here. Put a comma here. Same thing we also need to put in the default one. And we just call it transaction manager. Let's run it again. Let's define an endpoint that will push the data into this. So we take our hello world endpoint. Let's refactor, copy class, and let's call it time series endpoint. Now within this time series endpoint, let's call it time series. And let the method be post. Optional, let's call it time series entity. Put time series at request body time series entity TSE. Let's put we create a time series repository. And now in this we just insert it. So we say time series entity, we can just do return optional of time series repository dot save TSE. So this is our endpoint. Now we run this. Now let's get our postman. We can set the timestamp here so that we don't have to send it. So we can say tse.set timestamp new date. Oh, we have to also modify our entity so that the timestamp column name we can change. let's call it TS. Okay, it doesn't like to create a unique constraint. Okay, this has to be TS. If you're not auto-generating tables using Hibernate, it gets confused into the table names and the column name that you have given in your entity. So for example, I had to add this actual database column name here to make sure it is able to map it. Otherwise it was giving me error that the columns are not found. So if you see, there are most other columns names are same because there is no capitalization. But for auth token, auth capital T token becomes auth underscore token, refresh token becomes refresh underscore token on the database. So I looked up the database and found the actual values of the columns and put them there. And I also modified the constraints to have the right column names. Once we have it, then we can run it, and once it is up and running, we can bring the postman in, and still trying to run because I enabled debug logs. So it's up and running. Now if I run it, if you see, let's say for example, if I say K2 is equal to V2 and you run it. Now if you see here, the authentication is being done using X token, and this value is stored in one database, which is MySQL, while this particular value will go into another database, which is Postgres. So if I send it, this is the response that I get. And if I go to the table, this is the MySQL. If you see here, there is only one table here, which is Hibernate sequence in the user. If you go to the other one, which is the Postgres, and if I say select star from time series, we have this value. This is the value number 20. Before we did this, we also had to grant insert permission, because by default when you say grant all on database, that only gives permission on database. So this is the command that I ran, grant all on all tables in schema public to data stream. So now with this we can see that we have an application that can partially access data from Postgres and partially access data from MySQL, and that is what we had intended to start with. So with that, I think I will close this video, and if you have liked this video, please subscribe, hit the like button and share it with your friends. And if you are interested in such content, please comment and say what you want to see, and then we will post videos on those topics. Thank you for watching with this video, and peace.